Now this is the second video starting with the recapitulation part. First we'll start with polar rectangular conversion. Now in polar rectangular conversion, the polar coordinate, you know that the complex number of polar coordinate is represented by r angle theta, and in rectangular form it is represented by x plus z y. So r angle theta is converted to the rectangular form by r cos theta plus j sin theta. So you will get the Cartesian form. Similarly, from polar to rectangular, how to convert? The rectangular form is rectangular to polar. How to convert? The rectangular form is given x plus jy. So you have to convert it into polar. The r, that means the magnitude will find by root under x square plus y square, and the angle equals to tan inverse y by x. It is given in radian or degree. Here j we have used. J is the complex operator and its value is root under minus 1. Next, one thing, as we have to apply this calculations, this polar rectangular conversions, we need to apply in while solving problems related to AC. So that's why you should know that where to use addition, where to use subtraction, those you should keep in mind so that they're easy for calculation. It will be easy for calculations. So when you are adding or subtracting two complex number, then it is easy to go for rectangular form. And when you are multiplying or dividing to complex number, it is easy to do that in polar form. For example, here two additions are shown. These two complex numbers we have taken, addition is shown. Similarly, multiplication is shown in rectangular form. How you are multiplying and you are getting this answer. Now, the same multiplication we are doing in polar form. How in this? The two rectangular quantity will convert into polar. Simply you will use your calculator and you can convert it directly. And multiplication, while doing multiplication, the magnitude will be simply multiplication and the angle will be addition, simple addition. So the net will be multiplication of the two magnitude and addition of two angles. This is the answer. And while dividing the same quantity, again, if it is given in rectangular form, you convert it to polar form. The magnitude will be simple division and the angle will be subtracted. So like this we'll apply. Next we are coming to starter conversion. This also you have studied in basic electrical. So I have just written the formula that while doing problem in some steps you need to convert delta to star or star to delta. Otherwise you cannot able to proceed. So the formula just I have written here. R1. R1 means you are converting from delta to star. R1 equals to RB RC by RA plus RB plus RC. Similarly, if you want to convert from star to delta, then RA equals to R1 R2 plus R2 R3 plus R3 R1 divided by R1. So just remember these formulas. It is required for solving problem. And for example, this problem is given. You cannot able to find the equivalent resistance. You cannot proceed. So if this delta form is given, either one of the delta you have to convert to star, and then only you can able to proceed. So you try this. Next, coming to Cramer's rule. Cramer's rule will apply while we are applying KVL or KCL in our circuit. There will be forming some equations. So 2, 3, 4 equations we are getting. When there is more than 2 equations, in that case we will apply Cramer's rule. Here the variable are x, y, z. In our equation it may be current or may be voltage. So these variables we need to find, x, y, z value we need to find. How will do? First, you have to write the whole matrix. The whole matrix means whatever in the left hand side, the coefficient of the variables in the left hand side we are writing. So 2, 1, and here x, coefficient of x is 0. That's why 2, 1, 0. Then 3, 1, 2, 3, 1, 2. Then 5, minus 5, minus 1, 1. So minus 5, minus 1, 1. Now we have to find the determinant of this matrix. This is our whole matrix. Next, when you want to find the first variable, that is x, we are writing as dx. We have to find a matrix in which the first column of the main matrix would be replaced by the terms in the right hand side of your equations. So here the first column has been replaced by 1 to 8, and you have to find the determinant of that. Similarly, if you want to find y, you need to find dy. So here dy is the second term. That's why the second column of the main matrix will be replaced by the right hand side quantities, that is 1, 2, 8, and you have to find the determination. And the value you will get x equals to dx by d, y equals to dy by d, like this.